The question here was how to get our z-value. I think it was the z-value. I can't remember. From StatCrunch. So first of all, when picking the correct null and alternative hypothesis for this one, this is kind of tough because they haven't really told you in specific words what they want the alternative hypothesis to be. The null is always going to be the equal, that the two proportions are equal. However, in this one, we know that we have a clinical trial of a vaccine. So considering we more than likely would like the vaccine to work, right, we're supposing that the alternative hypothesis is that the incidences of children developing the disease that have the vaccine should be lower. So that's why I'm going to pick here for the null and alternative that, first of all, we assume that the vaccine has no effect and they'll be equal. That's our null hypothesis. And the alternative will be that we would like the proportion to be lower for the vaccine. So we'll first of all just check that. Then for the second part, we want to determine the statistic, which is z. So I'm going to go to StatCrunch here, and you can pull it up right from question help. And the key here is to pick the correct test. So first of all, we'll go to stat, and then here we are dealing with the proportion. So we are going to click proportion stats. And we do have two samples here because we're comparing one with the vaccine and one without the vaccine. And we weren't given all of the data, we were given a summary of that data. They told us how many successes out of the total number of trials. So let's see here, we're going to put in all of our information. So it looks like I had, let's see, 4,000 children in the experimental, 4,000 children in the control. In the experimental group, which would be the one that is the clinical trial, 76 developed the disease. So I'm going to put 76 successes, even though developing the disease is not a success, but you don't want to think of it in that terms. You want to think about how many displayed this trait out of 4,000. And then for the control group, let me move this here, it's 104 developed the disease. So we have 104 developed disease out of 4,000. Now when it comes to your hypothesis test and how to enter it here, first of all, I know this looks a little different because they're putting it in terms of P1 minus P2, the difference. But if you look back here, if we were to solve this equation over here, our H0 equation, whoops, for, to get this on the same side, I would get, if I subtract P2 from both sides, I get P1 minus P2 would be 0. And then if I get P1 and P2 on the same side here, if I subtract P2 from both sides, I get P1 minus P2 is less than 0. So I'm going to click back into here and put that equals 0, and I want less than 0. And click compute. So here we have, first of all, it gives you your total counts. It gives you your difference, your standard error, your z-statistic, which is what you were looking for, and your p-value. So just be careful with rounding. Sometimes that's an issue with StatCrunch when we type it into the MyStatLab. So they want us to round to 2 decimal places. So that will be negative 2.11 because we have a 0 there. So negative 2.11. And we're not going to make it negative here. We're just going to call it 2.11. Oh, no, I guess we do want it negative. So we'll do negative 2.11. Yeah, there we go. And our p-value. Our p-value we also could get from StatCrunch. And they want us to round to how many decimal places? 3. So we're going to go 0.017 because the number next to it is a 4. So here it would be 0.017. And there we go. And then they ask you the result of the hypothesis test. Remember when, in general, if the p is low, and we know alpha, we reject H0. So if the p is lower than alpha, you reject H0. If the p is larger than alpha, we fail to reject H0. And I hope that helps. Let me know if you have any more questions.